The effect of hand tracking on user performance, an experimental study of an object selection based memory game. My name is Nima Jamalian, and today I'm going to present this paper to you. So if you think about how we have interacted in virtual reality world, traditionally we have used controller as our input device. But modern VR devices allows us to be able to track our hand first without the need of having any external tracking tool, and also the accuracy of hand tracking they provide is much better than what we had before. So in this research, we try to investigate our user performance using an in-game analytic-based methodology. And we are comparing three conditions. First is controller without haptic, second is controller with haptic, and the third is hand tracking. Now, just to give you some background, it's also background research that we did, is that first we look at the effect of gesture on cognition. So there's a research by Golden Medio which shows that where they did an experiment where user needed to remember a sequence of letter, and the user actually managed to perform better in that experiment where they will be able to using their gesture. So when they were not allowed to use gesture, they perform worse. Therefore, they concluded that gestures appear to significantly actually affect our cognitive load. So if we are able to use our gesture, we can do better, we can remember better. And there is another research by Goldenberg which showed that our memory and action and perception have a relationship with each other. So what they concluded is that manipulation of the body or movement can affect our memory, so can have negative or positive impact. We also look at the mismatch that exists when using a controller. So if you look at in the graph, if we have the pose B, C, D, these are the different possible poses that you can hold the controller. And all of these poses will result in the A representation. So your hand gesture is going to be the same. And as you can see, this creates a mismatch. So what you see in VR is not actually what's represented in real world, which can have a effect on increase your cognitive load because there is a mismatch, and it's not a real accurate representation. And we also looked at hand tracking application design. So we wanted to find out what's the best way to design a hand tracking focused application. So the first thing that you need to pay attention is display field of view, which represented on the graph in the green line area between those. So this is should be the optimal position for where you put your interactable object for hand tracking. In the blue line area, we have the tracking volume, but if you have your hand is gonna get tracked if as long as in the blue line area. However, if it's not in the display field of view, even though the hand is being tracked, it actually does not get shown to the user, which can create a problem. And another thing to also you need to mention is something called gorilla arm effect. So this means that this effect is referred to as when the user needs to stretch their arm fully for a long period of time. This can cause strain on your lower arm and be painful for the user. So this is another thing to pay attention. So the general goal should be to have your interactable object in the upper body side, so a little bit to the head area, maybe a bit lower where the chest is. That should be the optimal position, and it should not be that far above where the user needs to fully stretch their hand. We also look at how multi-sensory interaction design works. So we know that haptic is one form of in sensory interaction, but there are other forms too. So we review top VR applications to sort of try to categorize this, and we come up with this graph. So we define three interaction types. So first is indication of interactable object, and usually this is being visualized to the user by visual cue. So it's either through change of color or shape manipulation. And then the next interaction type is confirmation of selection, and the feedback modality is either through visual, which is shape manipulation, and haptic, so the user gets the haptic feedback. And the next is confirmation of action, which usually gets visualized through sound, which would be the duration, frequency, and amplitude, basically how strong the sound is going to be. So based on these, we come up with three hypotheses. So our first hypothesis is that compared to using controller, hand tracking can reduce cognitive load by offering a more natural method of interaction with less mismatch of hand representation. Therefore, the participant should be able to perform better in our memory game because it's relying on working memory, and since the hand tracking, we hypothesizing that it reduces the cognitive load, they should perform better. Our second hypothesis is that since hand tracking mode is more natural, participants will be using both of their hand more equally, whereas using controller, participants will have a greater reliance on their dominant hand. And our third hypothesis is that participants would perform better using a controller with haptic rather than without one, because you have the advantage of haptic feedback. Now, for our experiment result, we come up with a within group study to examine this hypothesis, in which participants perform a memory puzzle task. We had three conditions: hand tracking condition, controller without haptic, and controller with haptic. And this task is based on Corsi block tapping task. So we basically implemented the 3D VR version of it. So just to explain you the task, so you have, as you can see in the video here, you have the button getting shown to the user and what the user needs to do. So they get shown and then they go away. The user needs to replicate that pattern that appear. They also need to replicate it in the same order. So there are two factors that we care here. First, whether they can repeat the same pattern correctly. We also want to check if they are repeating that pattern with the same order that the button got appear. So for example, if they get the order wrong, they get the visual feedback that what they did, even though they got the overall position correct, but the order they selected was wrong. And before the user performing this task, there was also training sessions for us to make sure they were familiar with the task. And in each session, for the experiment section, there were 12 trial, and when the user goes through this, as it goes through this trial, the task would get more difficult. So in the beginning, you have the complexity of 3, so only 3 button gets highlighted, but in the end, the more you go further to the experiment, the difficulty will increase for each session. So you have more button getting highlighted and you need to remember those. And another thing to also add is that we randomize which condition the user is going to play, so the learning of the experiment wouldn't affect our results. So some user tried hand, controller, and haptic. The next user might have tried the haptic, controller, hand. And we made sure to randomize this equally, so the equal number of participants got the different combination. Just to give you a pipeline, how we develop, overview of our pipeline on how we develop this experiment. We use Unity Game Engine. We also utilize two SDKs, is the XR Interaction Toolkit, which we use for the controller system. And we also use the Oculus integration for us to be able to use hand tracking on Oculus Quest. And this task was built as a PK for Oculus Quest, which means that the user this app was as a standalone app on the Quest, so the headset was not connected to a PC. The user would put on the headset, try out the experiment, and all of their data gets sent back to us. So our result showed that the participants were able to have better accuracy with hand tracking, uh, and also so both in the correct order and pattern. The user performed better with a hand tracking. With the correct pattern only, also the user performed better with hand tracking. So this supports our hypothesis 1, and one possible explanation is that in the controller condition, the mismatch between preserved actual pose causes has an effect on cognitive load. Basically, it increases cognitive load, therefore the user perform not as well as hand tracking in the controller condition. We also recorded which hand the user are using to basically solve this puzzle, perform the game puzzle, and the results show that participants tend to use both of their hand more equally in hand tracking mode compared to controller condition. And we believe that this is a direct outcome of hand tracking being a more natural interaction paradigm compared to controllers. And our result also showed that first time selection was faster with controller haptic compared to hand tracking. We believe this is a result of, this is also consistent with previous research, whereas haptic feedback can help us identify intractable object faster. Well, however, in the total trial completion time, actually hand tracking was faster, and we believe this is because in the hand tracking condition, we know that the user were using both of their hand more. So therefore, even though with the haptic they were faster to selecting the first button, but with the hand tracking, since they were using both of their hand more, in the overall time they actually saved time and they were able to perform faster, complete the total trial faster. And just to wrap this up, even though hand tracking had advantage in task, it doesn't mean that hand tracking is going to be better or more optimal solution for every task. There are some limitation to hand tracking, which I'm just gonna cover quickly. So first is the hand tracking volume. There's a limited space where hand tracking is performing very well. There's a lower tracking accuracy, latency issue, and there's a lack of haptic feedback when using hand tracking. And there's occlusion problem. So for instance, any gesture that requires overlapping of the hand right now is not possible using the hand tracking technology that we have. So you need to pay attention that the gestures of the hand needs to be separated, otherwise it's going to create occlusion problem. And there was the lack of feedback, which is something that currently doesn't really, there's no good solution for it. And also certain interaction that we have, such as teleportation in VR, relies on the use of button and triggers on controller, which provides a reliable and quick input. So further study are needed to test how we can redesign those controller based interaction to make them intuitive and robust for hand tracking. And yeah, that's it for this research. Thank you for listening.